Okay, anyone wants to give the answer for this one? Ada any ideas? Okay, for the first one.
F equal to mg.
Okay, betul lah. Simple je kan? Okay, follow je the instruction. Okay, first one, F equals to mg. Siapa tu? Okay, and
Adam
then?
tu.
Okay, good. Thank you. Okay, number two.
F equal to Gm1 over
Ha
R2.
lah kan, universal law of gravitation. G equals to
J
M1
M1
times M2 over?
M2 R2.
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 Okay, R squared. R squared. Kita sebut R squared R squared. Okay, and then equate to equations. Okay, what do you write here?
F equal to Gm over R2.
mg.
Kita like mg je lah. Dia kata equate the two
Dia balik.
equations. So this one mg anak panah ni letak kat sini. Okay, and then this one? G M1
M1
M2
M2
over R squared.
over
Okay, and then cancel common factor. Okay, kita ambil salah satu tu sebagai M lah. Okay, katalah ni M1 juga. So, what's the answer then? So, kita tinggal dengan
M square.
G equals to
G
G M2 over R squared.
R square.
So, macam tu lah. That's how we get the formula ataupun the the formula for gravitational acceleration. Okay. So what is the relationship between G, gravitational acceleration, and gravitational constant? What's the relationship? So the relationship is this formula ataupun directly proportional. Okay. So from the formula also, we know that factors that influence the value of gravitational acceleration. So what are the factors? What are the factors that influence the value of gravitational acceleration? Look at the formula. So what are the factors that influence the value of gravitational acceleration?
Mass saja tu.
Mass, very good. And is it mass only?
Distance.
Yeah, distance squared kan? The square of the distance. Okay. Right. So that's what we did just now. F equals to mg, and then we also learn about gravitational force of universal force, which is G times m1 times m2 over r squared. So daripada dua-dua tu, we get formula of gravitational acceleration. Okay. So itulah menjawab hubungan apa tadi? Menjawab hubungan antara G and G. Okay, next. Okay. For this one, activity 3.5, another activity, okay. Instruction, calculate the value of gravitational acceleration for the 5 distances. Okay, saya tak nak jawapan dalam numerical lah. Okay, give me the answer in R and G and M. Okay, so what's the value of R? So what is the gravitational acceleration when distance from the center of the earth is R? So let's say we have an object here. What is the gravitational acceleration? Apa expression for the gravitational acceleration? What is the expression of the gravitational acceleration? Yeah? Okay, G tadi, what is the formula for G? G M
square.
over R squared.
R square.
Okay, ini formula dia tadi kan? So now if the distance is R, apa kita punya expression?
Gm over R square.
Yelah, okay, good. Thank you. Gm over R squared. Now you please do for 2R, 3R, 4R and 5R. Okay, so when we have 2R, what's the answer? Saya bagi 5 minit
GM square.
Oh, nampak dah kat
GM
sini ya.
over 2R square.
GM over
2R square.
2 ke?
4.
4R square.
4R squared. Kenapa?
R square.
Just now the formula is GM over R squared. But now our R is 2R. Therefore, we have GM over 2R squared. Okay, so if you do that, okay, awak buat. So, bising tak saya ni? Bunyi tak? Bising tak? Tak ada. Okay. So, when 3R, when the distance is 3R, we get the answer GM over 9R squared. For 4R,
16.
16R squared. What about 5R?
25R
25R squared. Okay, you square both of the number and R. Okay, so from here, okay, apa yang kita nak buat, apa yang nak tunjuk sebenarnya? Okay, okay, right. So now you see when the okay, how do you say, what is the relationship between the distance from the center of the earth with the value of gravitational acceleration? What's the relationship between the distance and the gravitational acceleration?
The higher the distance, higher the gravitational
Lagi jauh
acceleration.
lagi, the higher the distance,
the greater the gravitational acceleration.
so this one greater. Is it greater?
I don't know.
Decrease kan?
Decrease greater or increases or decreases?
Decrease.
So let's say this one is 1. Kalau lah GM, kita katakan GM tu, ini matematik GM over R squared tu kita katakan dia adalah 1. Kan? Sekarang ni kita ada GM over R squared per 25. Kan ni 1 tadi kan? So 1 per 25 times 1. This one 1. 1 compared to 1 over 25, which one is bigger?
1.
Lah kan? So, what's the relationship between the distance and the value of gravitational acceleration? The higher the
distance.
The higher the distance, the lower the gravitational
acceleration.
Is that logical?
Yeah.
Yalah kan? Okay. So that's logic lah, right? So that is what happened kan? If you go outside of the atmosphere, you pergi ISS ke, pergi luar daripada bumi ataupun atmosphere, you will feel less gravitational pull. Okay, so when you have this data, you can plot a graph. Okay, plot a graph of G against R. So how is the graph look like? Okay, so okay, I have plotted this one for you. Kan? Okay, tengok graph tu macam mana, okay, if you are asked to sketch this graph, okay, make sure you know how to sketch the graph. Okay, it's not that difficult. Okay, kita dah buat tadi, when GR, the distance is R, we have GM over R squared. So that is the maximum value. Okay, that is here. Right? So that is when you are at the surface ataupun you are betul-betul on the surface of the earth. Okay, that's the value. Okay. And then at this region, kita tengok this region, value of G is directly proportional to the distance from the center of the earth for R less than R, capital R. For R2, what is R? R is radius. Ni dekat mana ni? So if this is the earth, okay, this is radius of earth. Okay, so R is this point here. R is on the surface of the earth. So faham tak graf tu? Maksudnya value is directly proportional. If the object is in the earth, dalam earth dekat sini, kan, dekat point B, the value is less than gm over r squared. Okay, so ini dalam bumi, inside the earth, okay, below r. Okay, what happened? So this one is outside of, above the surface. So at 2r, we have gm over 4r squared. Macam mana awak nak draw graph ni? So kita ada seolah-olah kita bahagikan, okay, let's say this is the whole graph. Okay, this is the whole graph. Kita ambil 1/4 of the graph. Okay, saya buat 4 bahagian. 1, 2, 3, 4, 4 sections. So 1/4. Nampak tak? Dia 1/4. 1/4 is this one only. So nampak tak kita ada graph tu? Somewhere here. Do you understand what I'm trying to say? Okay, sama juga. Okay, nampak ni Ni 1, 2, 3, 4. Ada 4 boxes seolah-olahnya. Ada 4, kita pecahkan kepada 4 bahagian. So, for 2R, only 1/4. So, that's it. Okay, ini point dia. Okay, so ini point for this one. Okay, next, when 3R, okay, when 3R, we have gm over 9r squared. So, seolah-olah daripada one whole ni, ini satu kan? Ini satu bahagian. Okay. So, katalah ini satu bahagian. So, now, satu bahagian tu, we divide into 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Jadi, dia only 1/9 sahaja. So, where is 1/9? So, 1/9 is here. Okay? Oh, and then next, 4R. 4R, when distance is 4R, gm over 1/16. That means daripada 1 tu, we divide into 16 parts. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 16. So, this one. 1/16 sahaja. 1/16 only. And then we do the same for 5R. Distance 5R, we have gm over 25. So, kita ada 25 boxes. Okay, so kat mana tu? Kat sini lah bahagiannya. Almost 0 dah. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, sampai 25. So, dia ambil satu part 25 tu sahaja. Okay, so that's how you, that is the easier way to understand this lah. Okay, so kita ambil in parts lah. Kita gunakan fraction. Okay. Sometimes you are asked, okay, you are given values. Okay, bila diberi value, of course lah, the value here will be much less, kan? This is the least. This is the largest. And at the Earth's surface here, what is value of G? What is the value of G? Anyone knows the value of G at the Earth's surface? Approximately? Dah belajar topik motion, kita selalu buat pengiraan. We always calculate using acceleration. Let's say,
9.81 meter per
kan
second.
selalu soalan kalau macam objek jatuh, okay, what is the gravitation, what is the acceleration of the object falling down?
10 Newton.
Yeah? What is the
Newton.
value of the acceleration? So actually acceleration yang you kira selalu tu, so that is G lah tu. So it's approximately 10. Okay? 10
Newton.
Newton per kg. Or sometimes kita buat 10 meter per second square. Okay? So sebenarnya kita buat eksperimen, jawapan dia bukanlah 10. Dia punya, bila dapat eksperimen, kita dapat 9.81 meter per second square. So kita bundarkan je jadi 10. Okay, so from here we see that, okay, this part here, kita ada dua part yang berbeza lah. Okay, first, in directly proportional, this one. And then the next part, from R to 5R, inversely proportional. Okay, so that's the relationship. Okay, so look at this diagram. You look at this diagram, kita ada satellite di situ. Okay, so from here we see that distance of satellite from the center. What's the distance of the satellite from the center of the Earth? Nampak kan? So the distance is h plus r. So what is h? H is
Height. Height.
height ataupun distance from the satellite from the surface of the Earth. Okay, and then what is r? R is radius of the Earth. Okay, and then from there we get the answer. Okay, so berapa? Kalau awak nak kira value of G of siapa? Gravitational acceleration of the satellite. So satellite ni dia ada gravitational acceleration, dia accelerate. Okay, what is the value? You can use this formula. So R kita sekarang ni jadi R plus H, you squarekan that one. Okay. Now, okay, on the surface of the Earth, H is 0. Okay, kat sini H is 0, then R equals to R. So ini yang kita dah tahu tadi. Okay. Oh. Dapat dah? Answer. Tolong jawab. Tolong jawab. Okey, kejap. Sini. Nanti
9.81.
Ya?
9.81.
9.81. Okay, very good. Okay, so direct je soalan ni. Okay? Okay, so kita tahu M equals to 5.97 times 10 to the power 24, and then kita tahu G, lepas tu kita dapat R. Okay, daripada situ kita tulis formula. Apa formula dia? Okay, tulislah. Okay, dalam exam awak kena buatlah ni semua. First step, second step. Okay, memang kita ajar cara ni. Dah ajar dah. Tapi nanti dalam exam tak buat juga. Okay, step 3. Kita masukkan nilai. Okay, tekan kalkulator betul-betul. Dapatlah jawapan yang macam kawan awak jawab tu. 9.81. Unit apa? Nama dia pun apa? Acceleration kan? Apa unit acceleration? So, meter per second squared. Okay. Alright, let's continue example number 2. Example number 2. Okay. Answer, anyone? So what do you know? Okay, we are given the height of the satellite. The satellite is 480 kilometer. 480 kilometer from the Earth's surface. So what is the value of gravitational acceleration? Berapa?
8.49.
Okay, so dapat mana formula ni? Ingat tak ni? Kenapa R plus H? R plus H? Kejaplah. Kejap. Tekan kalkulator dapat berapa? Okay, make sure tekan kalkulator betul-betul sebab soalan ni senang tapi
8.49.
ya,
8.49. Mantap.
so the answer is hafal lah. Lah. Muka ni. Okay, dapat jawapan dia 8.49 meter per second squared. Okay, dapat tak?
Dapat.
Dapat. Oh, patut solat dulu tadi.
Saya dekat masjid tu.
Oh, dekat masjid. Masya Allah. Bagusnya. Siapa tu? Oh, semayang dulu.
Adam.
Ada, mari semayang dulu dah.
Ilmu.
Dah. Memang. Pergilah ajar yang semayang tu. Ni yang saya punya ni, nak habis dah ni. Okay, sorry tadi ter-disconnected. Okay, the importance of knowing the value of gravitational acceleration. So, dah tengok ke? Apa dia importance of knowing the value of G? So, Fg is a universal force. Okay, and then kita dapat G ke Gm over R squared. So, this one is to calculate. Okay, so we use this formula to calculate the gravitational acceleration on the surface of other bodies like moon, planets, or other planets, etc. lah. Okay, and then when G on the surface of planet is known, we can get the magnitude of Fg. We can get the values of Fg. Okay.
Cikgu.
And then okay, and also when we know gravitational acceleration, we can also get the effects of growth of human. Okay, G also affects the growth of human. That means if you are somewhere else, you are not in the earth, maybe your rate of growing is different Okay, slightly different. Okay, so those are the importance. Okay, and then
Saya hantar tu.
apa dia? Itu siapa tu?
Nombor salah satu.
Tak dengar ke apa ni? Okay. So mana yang paling, what do you see from the values? Okay. So this is, the values shows us Neptune is very far from the Neptune is the furthest from the Earth kan, and then Pluto ya ke? Salah. So siapa yang paling jauh daripada the Earth?
Jupiter. Betul.
Jupiter. Okay, Jupiter is paling jauh, tapi kenapa value dia paling besar?
Sebab dia besar.
Why?
Sebab Jupiter besar. Mass dia. Saya ada.
So the value
Jarak.
actually doesn't tell you values ni doesn't tell you the distance kan? Okay, kenapa this one Jupiter far from the Earth, tapi kenapa nilai dia besar?
Sebab planet besar.
What is the factor affecting G? Planet tu besar
berat
jadi
berat.
the value the value is bigger because of the mass is the highest. Okay? So dia bukan sekadar bergantung kepada R, dia juga bergantung kepada the mass. Okay. Okay. This one saya nak suruh buat homework sikit lah. Buatlah bila-bila free. Please find information of effect of gravity on the growth of human. Okay? Boleh tak ambil gambar ni? Print screen ke? Ambil gambar ni sekejap. Dah print screen dah?
Dah.
Okay, so this is, Okay, I want you to present in multimedia presentation. You boleh buat group. Berapa group ni? 1, 2, 3, 4, 5. Buat 5 group. Bolehlah pilih sendiri ahli group tu Ke nak saya tentukan?
Sendiri.
Buat sendiri group tu. Saya tahu.
Sendiri.
Okay. So next week ada seorang yang akan present, okay?
Cikgu saya macam ni cikgu.
Kalau you all tak boleh nak share screen, nanti boleh hantar pada saya siap-siap lah. Saya bukakan, you all akan bacakan ke whatever lah. So the multimedia presentation tak semestinya PowerPoint. Bolehlah juga kalau nak buat canggih-canggih yang lain ke kan. Kalau awak reti lah. Kalau TikTok tu boleh buka pun, boleh juga kan. Kalau TikTok tu mudah kan. Sebab dengar cerita TikTok tu cara buat video dia lagi mudah Saya pun tak tahu, tak pernah try. So tak kisah, boleh guna apa-apa sahaja presentation tapi multimedia so that you can mahjong paper tak terima, tak boleh nak tunjuk nanti. Okay? Alright. So this is interesting. Okay, kita nak tahu apa kaitannya dengan our life. Okay, and then this one, okay, centripetal force. Okay, this is a new what a new terms for you. Okay, centripetal force. Tak sangat new lah. Kalau awak ambil IGCSE, kalau awak sempat belajar, okay, awak tak ambil IGCSE, but if you have learned about centripetal force, haven't you? So what is centripetal force? It is a force. Kan? The unit is Newton. Okay, it is a force. The unit is Newton. So what is it? Centripetal force.
A force that makes a body follow a curve path.
Okay, good try.
Terangkan
Okay,
terangkan.
what is the direction of centripetal force? Cuba tengok. Okay, saya tunjuk diagram ni. Boleh play tak? Okay, please. Okey lah, boleh pergi sendiri nanti ya. Saya ni tengah hari lah. Dah tengah hari sangat susah lah. Okey, kat sini awak boleh tengok macam mana okay, gravitational force dengan velocity tu. Okay. So, kalau ada pergerakan, so itu orbiting ni moon. This is the sun and this is the earth. Okay, yang biru tu simbol apa? Biru tu anak panah menunjukkan gravitational force. Okay.
Damn boy.
Ya, mama. Kejap. Yelah, kesian dia. Okey. Okeylah. Okay. So, tengok sendiri ya. Nanti pergi dekat FAF ni. Okey. Tak boleh nak tunjuk. Dia ada tinggal ni model ni. Lepas tu kalau ada satelit macam mana. So, mana centripetal force tu? Okay, minggu depan kita tengok centripetal force tu adalah ni, daya yang menuju ke arah center of gravity. Okay, saya stop dulu kat sini. Boleh awak sambung assignment Okay, Assalamualaikum warahmatullahi wabarakatuh. Tanggung atas speaker para saudara.
Thank you, cikgu.
Thank you, cikgu.
Okay, boleh buat assignment.
Cikgu.
Ya.
Cikgu.
Thank you, cikgu. Bye, cikgu.
Baik.
Terima kasih, cikgu.
Ya.
Terima kasih, cikgu.
Cikgu.
Terima kasih, cikgu.
Saya tak tahulah kronik kat mana. Kronik